In this class, we're going to talk about matrix. We're going to look at what is meant by matrix, types of matrix, orders of matrix, the addition, subtraction, multiplication, equality of matrix, transpose, determinant, inverse, and even how to solve simultaneous linear equation using matrices. Are you getting it? So the big question is, what is meant by matrix? Matrix refers to a set of real numbers or complex numbers which are arranged in rows and columns to form a rectangular array. Now, please pay attention. I'm going to take notes. I want to take note of the important points in that definition. Matrix refers to a set of real numbers or complex numbers. These numbers are arranged in rows and columns. So, I want to take note of this. Rows, columns. A set of real numbers or complex number. Real numbers or complex number. A set of real or complex number. These numbers are arranged in rows and columns to form a rectangular arrays. To form a rectangular arrays. So I'm going to explain. When we talk about matrix, we are referring to a set of real numbers, and these numbers is arranged in rows and columns to form a rectangular arrays. Now listen, let's say we have A equals to A1, B1, C1, A2, B2, C2, A3, B3, C3. A typical example of what we are talking about is what I'm talking about in the definition is this. Look at this. This is a typical example of matrix. This matrix has elements. The elements are the set of numbers that are present in the matrix. Do you understand? So A is part of the element B, C, A1, B1, C1, A2, B2, C2, A3, B3, B3 and C3. They are just numbers which can be real or complex. Do you understand? So when we talk about matrix, we are looking at a set of real numbers or complex numbers which are arranged in rows and columns. Now, how many rows do we have in this matrix? We are having 3 rows, right? Because this is row, this is row, and this is column, this is column. Okay, so how many rows do we have in this matrix? We are having 3 rows. This is row 1, row 2, row 3. Do you know? And this is what? Column 1, column 2, and column 3. Do you get it? So in this matrix, we are having 3 rows and 3 columns. I'm just trying to justify the definition that I gave to you, that in matrices, we are looking at a set of real numbers or complex numbers that are arranged in rows and columns. Okay, having understand what is meant by matrix, let us look at the orders of matrix. Now, please, I want you to pay attention. This is very, very important because understanding all these basic concepts will help you to comprehend as we progress in the topic. So I want you to pay attention. When we talk about orders of a matrix refers to the dimension of the matrix. You understand? Every matrix has 2 parts, rows and columns. Are you getting it? Listen to the explanation again. Every matrix has 2 parts, the rows and the column part. Do you understand? So when we are talking about the orders of a matrix, we are looking at the dimension of the matrix. Let's consider the matrix that we have on the board. Matrix A equals to this. Now, how many rows do we have in this matrix? We are having how many rows? 3 rows, right? How many columns do we have? We are having 3 columns. So the dimension of this matrix will be what? Please pay attention. 3 by 3. Okay? That is the dimension of the matrix. I'm going to explain. These 3 that you see here stand for row by column. If you're asked to name the dimension of a matrix, first talk about the rows. Are you getting what I'm trying to say? Talk about the row properties. How many rows does the matrix has? Then you put this sign. This sign means by. Then you put the column. How many columns does the matrix has? 3. Do you understand it now? Let me give you another example. Let's say we have matrix B equals to B1, B2, B3, B4, B5, B6. Then I'm coming B7, B8, B9, B10, 11, 12. Okay, look at the matrix that we have on the board. Look at this matrix. Matrix B equals to this. How many rows does this matrix have? How many columns does it have? You see, before you can identify the dimension of a matrix, you must be able to tell us the numbers of row and the numbers of column. Do you understand? This matrix contains 4 rows. This is row 1, row 2, row 3, row 4. So I'm going to have 4 by. Now, how many columns do we have on this matrix? This is column 1, column 2, column 3. You understand? So that is what? 4 by 3. So this matrix, the dimension of this matrix is what? 4 by 3. And I told you that the dimension of the matrix refers to the orders of the matrix. Do you understand it now? So let me give you one more example. What is the orders of this matrix? Matrix C equals to 1, 2, 1, 4, 1, 1. Okay. What is the dimension or order of this matrix? The order of this matrix is 2 by 3. Okay. How do I know? I told you that you are first going to mention the row first, followed by the column. So now, how many rows do we have on this matrix? We are having 2 rows. This is row 1. This is row 2. You understand? So I'm going to have 2 by, how many columns do we have? We are having 3. 1, 2, 3. So 2 by 3. That is the order of the matrix. Do you understand? Okay, let's look at this practice question that we have on the board. We are asked to state the order of the following matrices. Okay, let's start with the first question. I told you that order of a matrix refers to the dimension of the matrix. You understand? So for this, I'm going to have how many row by column. Okay, how many rows do we have in this matrix? 1, 2, 3. Abi? So I'm going to have 3 by. How many columns do we have? 1, 2. So that is 3 by 2. The order of this matrix is 3 by 2. Do you understand? Okay, listen to the explanation again. Do you understand? How many rows do we have in this matrix? This is the first row, this is the second row, and this is the third row. So we are having 3 rows. You understand? So I have 3 here. Then how many columns do we have? We are having, this is the first column, this is the second column. Are you getting it? So we are having 2 columns. So the order of this matrix is 3 by 2. Do you understand? Okay. Now let's look at the second example. What is the order of this matrix? The order of this matrix is that you first have to name the row. How many rows do we have? 1, 2. So I'm going to have 2 by, how many columns do we have? 1, 2. This is column 1, this is column 2, and this is row 1. This is row 1, and row 2. You understand? So we are having 2 columns and 2 rows. Do you understand? Okay. In the third example, how many columns do we have and how many rows do we have? We are having 2 rows. This is row 1 and this is row 2, you know. And this is column 1, column 2, column 3. So this one will be what? 2 by 3, sorry. 2 by 3. Do you understand? First mention the row first, followed by the column. Are you getting it? Now let's look at the fourth example. The first example, how many rows do we have and how many columns do we have? We are having only 1 row. You understand? This is only 1 row. So I'm going to have 1 by. Now, how many columns do we have in this matrix? This is the first column, second column, third column, and fourth column. So we are having 4 columns. So that is 1 by 4. Do you understand it now? So if you want to state the order of a matrix, it is crucial to know the numbers of row and the numbers of column that is present in the matrix. Do you understand? Okay. Having understand what is meant by orders of a matrix, let us look at types of matrix. Types of matrix. Type of matrix. In this class, we are going to look at the different types of matrix. So I want you to pay attention. The first type of matrix that we're going to be considering is zero matrix. What do I say? Zero matrix. Zero matrix. Zero matrix. Now listen. Zero matrix is a kind of matrix which has all the elements in the matrix as 0. Are you getting it? I'm going to take that again. Zero matrix is a kind of matrix that has all the sets of numbers that are present inside the matrix as 0. Are you getting it? Okay, so if you didn't get it, just pay attention. A typical example of zero matrix is this. 0, 0, 0, 0, 0, 0, 0, 0, 0. This matrix that you see here is called zero matrix. Why? The reason is because all the elements that are present all the numbers that are present inside the matrix are zeros. Do you understand? So this is a typical example. Another example is this. You can have 0, 0, 0, 0. Are you getting it? So, and if you are given a matrix that contains zeros as all the elements, that matrix can be termed zero matrix. Do you understand? Okay, please pay attention to all these things that we are that I'm saying, because it is very, very important. When you get to addition or other simplification of matrix, you're going to need some of it, if not all. Are you getting it? So please pay attention to everything. Okay, another type of matrix that we are going to talk about in this class is square matrix. You understand? Square matrix. We have talked about zero matrix. Now let's talk about square matrix. Square matrix. Okay, from plane shape, a square is a plane shape that has all its sides equal, right? Yes. Now when we talk about square matrix has the same dimensions. You understand? Like the numbers of rows is equal to the numbers of columns. That kind of matrix is called square matrix. Do you understand? Okay, so let's look at example. Let's say we have a matrix 1, 2, 2, 1, 1, 1, 2, 4, 1. This kind of matrix is square matrix. Let us check. Any matrix that satisfies this condition can be regarded as matrix, can be regarded as square matrix. And this is a condition. The numbers of rows must be equal to the numbers of columns. You understand? That is the same numbers of rows and columns. Any matrix that has that is called square matrix. Do you understand? Okay. Now look, how many rows do we have in this matrix? We are having 3 rows, right? How many columns do we have? We are having 3 columns. Let us name it. This is row 1, this is row 2, and this is row 3. And this is column 1, this is column 2, and this is column 3. So this matrix contains 3 rows and 3 columns. Hence, it can be regarded as square matrix. Do you understand? Okay. Let us look at another example. Let me give you work. Okay. What of this? 2, 1, 2, 2, 1, 1. Look at this matrix. Can this matrix be regarded as square matrix? No. The reason is because the numbers of rows is not equivalent to numbers of columns. You understand? So we are having only 2 rows here, row 1 and row 2. And why we have column 1, column 2, and column 3. So this matrix cannot be regarded as square matrix. Any matrix that can be regarded as square matrix are those matrices that has the same numbers of rows and columns. Do not forget, okay? So now that is about square matrix. You can also have as many examples. You can have 2, 1, 2, 1. This is also a square matrix because, listen to me carefully, this is a square matrix. Why? Because it contains the same numbers of rows and columns. This is row 1, this is row 2, and this is column 1, and this is column 2. Do you understand? Okay? So now let's look at more. Another type of matrix that we're going to talk about is non-square matrix. Non-square matrix. Number 3. Non-square matrix. Non-square. Non-square matrix. Let me erase this. I'm coming. Non-square matrix is a kind of matrix that the numbers of rows and columns are not equal. You understand? That is, the numbers of rows in the matrix and the numbers of columns are different. They differ. You understand? That kind of matrix is called non-square matrix. You understand? Okay. Don't forget. A typical example of non-square matrix is this. Let's say we have matrix. Let's say we have a matrix 1, 2, 1, 1, 2, 1. This matrix is a non-square matrix, and the reason is because if you look at the numbers of rows, this is row 1, this is row 2, and this is row 3. Do you know? And how many columns do we have? You're having 2 columns. This is column 1 and this is column 2. So this kind of matrix is not non-square matrix. You understand? That is, the numbers of rows is not equal to the numbers of columns. Numbers of rows is not equal to the numbers of columns. Just master this. The numbers of row is not equal to the numbers of columns. In the square matrix, the numbers of row is equal to the numbers of columns. That is, if the rows are 3, the column must also be 3 for it to be for the matrix to be called a square matrix. Do you understand? Okay, so for a non-square matrix, the numbers of rows is not equal to the numbers of columns. Do you understand? So you can give me more example. Give me more example. Let's say another one is this. 1, 2, 1, 2, 1, 1, 4, 1. Okay, this is also a typical example of non-square matrix. The simple reason is because if you look at this matrix, we are having how many rows? we're having two rows, you know. This is row 1 and this is row 2. And this is column 1, column 2, column 3, column 4. Do you understand? Another type of matrix that we're going to talk about is identity matrix. Identity matrix. Please pay attention. Number 4, identity matrix. Identity matrix. Now listen. Identity matrix is a matrix that has the leading diagonal to be equals to 1, while other elements are zeros. You understand? Listen to me carefully. I'm going to explain. Just pay attention. I know that you've not heard of the concept of leading diagonal before, so pay attention. If you have a matrix leading diagonal, I want to explain this concept now. Let's say we have a matrix 1 0 0 0 1 0 0 0 1. The leading diagonal of this matrix is this. This is the leading diagonal. Are you getting it? From this top left, the element that comes from this top left to the bottom corner is 1, while other elements are 0. That kind of matrix is called identity matrix. Are you getting it? Listen to the explanation again. Any matrix that has all the elements to be equals to 0 except the element in the leading diagonal, that matrix is called identity matrix. Okay? Now, leading diagonal 2 1 2 4 1 2 3 1 1. Now, the leading diagonal in this matrix is what? This is the leading diagonal. Are you getting it? This is the leading diagonal. The leading diagonal is the element that ranges from the top left to the bottom corner. Are you getting what I'm trying to say? So, this is the leading diagonal. This kind of matrix that you see here cannot be regarded as identity matrix. You understand? Because even though we have leading diagonal here, but the elements that are present in outside the leading diagonal, they are not zeros. You understand? So identity matrix is a kind of matrix that has all other elements as 0 except the element in the leading diagonal. The element in the leading diagonal must be 1, while other elements are 0. For we to call that matrix identity matrix. You understand? The reason why I bring this out, the reason why I brought this out is because I want to explain the meaning of leading diagonal. Leading diagonal is the matrix. Leading diagonal in a matrix is that element that comes from the top left corner to the bottom corner of that matrix. Do you understand? Okay? Let me erase this. So, this kind of matrix that you see here is called identity matrix. Why? The simple reason is because it satisfies the condition. The condition for a matrix to be called identity matrix is that every other element must be 0 except the element in the leading diagonal, and that must be 1. Are you getting it? So please pay attention to that. I have already introduced you to a concept known as leading diagonal. Leading diagonal is that diagonal, the elements that are present from the top left, yes, to the bottom corner. Do you understand? So if you have all other elements as 0 except the elements that are present in the leading diagonal, that kind of matrix is called identity matrix. Do not forget. Okay, let's look at another one. Let me give you another example. So master, make sure you don't forget the concept leading diagonal. Okay, now look at this example. Can we regard this matrix as identity matrix? 0 1 1 0. Can this matrix be regarded as identity matrix? No. The reason is because the elements in the leading diagonal are zeros, and the condition for which to call a matrix identity matrix is that the elements in the leading diagonal must be what? Must be 1. You understand? Why other elements are zeros? Are you getting it? So the elements in the leading diagonal are what? They are zeros here. So we cannot call the matrix identity matrix. Do you understand? Okay, let me give you another example. Can this matrix be called identity matrix? Yes, it can. The simple reason is because this is the leading diagonal. And in the leading diagonal, all the elements that are present here, that is all the numbers. You understand? When I say element, I am referring to a number. You understand? A set of numbers that are present in the matrix. Do you understand? So don't get confused. So all the numbers that are present in the leading diagonal, they are 1, while other elements are 0. So this matrix that can be called identity matrix. You understand? Any matrix that satisfies this condition, the leading diagonal are 1, other elements are 0s, is called identity matrix. Don't forget, okay? So I can erase this now. So this one cannot be called identity matrix. Now I hope you understand it now. Let me give you another one. You can have 4 by 4. You understand? This matrix can be called identity matrix. The reason is because the elements that are present in the leading diagonal, this is the leading diagonal, you know. This is the leading diagonal. The elements that are present in the leading diagonal, they are 1, while other elements are 0s. You understand? So this is a typical example of identity matrix. Do you get it? Okay. Another kind of matrix, another type of matrix that we're going to talk about is row matrix. You understand? Row matrix. Row matrix is a kind of matrix that has only a single row. Do you understand? That's it. Any matrix that has only a single row is called row matrix. So, for example, let's say we have matrix 1, 2, 3, 4. This matrix can be regarded as row matrix because the numbers of rows that are present here is what? Is 1. How many columns do we have? We are having 4 columns. 1, 2, 3, 4. Are you getting it? But the numbers of rows that are present is 1. So the this kind of matrix is called row matrix. Do you understand? Another example. What kind of matrix is this? Row matrix, because it has only a single row. Are you getting it? Any matrix that has a single row is called row matrix. Now, let me give another example. Can this be regarded as row matrix? Can this matrix be regarded as row matrix? No. The reason is because it has 3 rows. You understand? The matrix contains 3 rows, so we cannot call it row matrix. Any matrix that has only a single row can be regarded as row matrix. Okay. Now let us look at the 6th type of matrix. That is column matrix. Column matrix. Okay. Column matrix is a matrix that has only a single column. See, don't forget everything that I'm saying. Okay. Don't worry. By the time we get to simplification, you're going to see the application of everything that we have been talking about. Okay. So column matrix is a matrix that has a single column. Are you getting it? So let's say we have a matrix 1, 2, 4. This kind of matrix is called column matrix. The reason is because it has only a single column. Are you getting it? This is the column. How many rows does this matrix has? It has 3 rows. You understand? This is row 1, row 2, row 2, and this is row 3. But it has only a single column, which is what? Column 1. Do you understand? So a matrix that has only a single row is called row matrix, and a matrix that has only a single column is called column matrix. Do not forget. Okay. Now let me give you another example. This also is a column matrix, and the reason is because it has only a single column. Do you understand? Okay. So we have talked about zero matrix as matrix that has all the sets of elements that are present inside the matrix as zeros. Square matrix has the numbers of dimension. You understand? That is, square matrix has the same dimension, that is the same numbers of rows and column. While non-square matrix differs in their numbers of rows and column, and identity matrix is a matrix that has all other elements that are equal to be 0. Identity matrix is a matrix that has all other elements to be equal to 0, while the leading diagonal are 1s. Are you getting it? The elements that are present in the leading diagonal, they are 1, while other sets of elements that are present inside the matrix are 0. That kind of matrix is called identity matrix. Okay. Now we have row matrix. Row matrix is a matrix that has only a single row, no matter the numbers of columns that it has. Provided that it has only a single row, it can be called row matrix. Are you getting it? Now for the column matrix, is a kind of matrix that has only a single column. So don't forget this. Okay. Now with respect to everything that we've learned, let us use that to answer this question. You are going to tell me the type of matrix that we have here. 1, 2, 3, 4. Okay. Now, for the first matrix, what kind of matrix is this? Is it zero matrix? Is it square matrix? Is it non-square matrix? Is it identity matrix? Is it row matrix or column matrix? Let us check. For zero matrix, all the elements must be equal to 0. So this matrix cannot be called a zero matrix. Do you understand? Okay. For square matrix, they must have the same numbers of rows and columns. Is that not it? So how many rows do we have here? 1, 2, 3. How many columns? 1, 2. This is column 1. This is column 2. This is row 1, row 2, row 3. So they didn't have this matrix didn't have the same numbers of rows and columns. So we cannot call it square matrix. Do you understand? Okay. Now, what of the third one, which is non-square matrix? Can this matrix be called non-square matrix? Yes. The simple reason is because I define non-square matrix as a matrix that differs in numbers of rows and columns. Okay. So this matrix that you see here can be regarded as non-square matrix. Do you get it? Because it contains how many rows? 3 rows. How many columns? 2 columns. You can see that 3 is not equivalent to 2. So this is non-square matrix. Do you get it? Okay. Now let's move to number 2. Let's move to number 2. For number 2, what kind of matrix is this? This one cannot be regarded as zero matrix. Why? The reason is because it doesn't contain 0. You understand? All the elements that are present there are not 0. That is, all the numbers that are present inside the matrix, they are not 0. Now listen. 5, 4, 3, 2, 1. They are numbers inside the matrix, right? Are they zeros? No. So we cannot call it zero matrix. Are you getting it? So can we call this square matrix? Can it be called square matrix? Yes, it can be called square matrix. Why? The simple reason is because it contains the same number of rows and columns. Do you understand? So how many rows do we have? We are having 2 rows. 1, 2. How many columns do we have? We are having 2 columns. 1, 2. Do you understand? This is column and this is row. Do you understand? Okay. So this is square matrix. This one is non-square matrix. This one is non-square matrix. This one that you see here is square matrix. Now, what of the third matrix? Okay. For the third example, what type of matrix is this? Is it zero matrix? No. Is it square matrix? No. Is it non-square matrix? Yes. The reason is because it has 2 rows and 3 columns. You understand? These are the rows 1, 2, and these are the columns 1, 2, 3. So this one is called non-square matrix. Non-square matrix. Okay. Now for the last example, we have 4, 1, 2, 3. What kind of matrix can we call this? Is it zero matrix? Is it non-square matrix? Is it column matrix? Is it row matrix? This matrix is called row matrix. Why? Because it has only a single row. Do you understand? This is the single row that it has. So this matrix is called row matrix. Do you understand it now? Okay, so we have talked about what is meant by matrix. We have looked at the order of a matrix. We have looked at type of matrix. Now let us look at equality of a matrix. On what condition do we say matrices are equal? 2 matrices are said to be equal if all the corresponding elements are equal. Are you getting it? Let's say we have matrix A. Please pay attention. Let's say we have matrix A equals to 1, 2, 1, 2, 1, 1, 2, 4, 5. Okay? And we have matrix B to be equals to 1, 2, 1, 2, 1, 1, 2, 4, 5. Matrix A and B can be said to be equal if all the corresponding elements in A are equals to the element in B. You understand? What I mean by corresponding element is this. There is something called position. You understand? Please pay attention. It's simple. It's simple, okay? It's not hard. Just pay attention. Listen. Position of element. Position of element is the standings of the elements in the matrices. You understand? Where the element stands in the matrices is called the position of the element. For example, if you look at this one that you see here is not the same thing as this one. Okay? They are different because their position is different. Do you understand? The position of this one is in row 1, column 1. You see? This one that you see here is in row 1, column 1. The first row is this, row 1, you know. This is the second row, right? Row 2. And this is the third row, row 3. You understand? Now, the first column is what? This is the first column, column 1. This is the second column, column 2. And this is the third column, column 3. Do you understand? Now, if you look at the position of this one, it is in row 1, column 1, right? What of these two? This 2 is in row 1, column 2. This one is in row 1, column 3. So, now listen to me carefully. When we say that two matrices are equal, the corresponding element must be equal. That means that the position of this one must be the same position in the second matrices. Are you getting it? Now, from this example that we have on the board, can we say that A is equals to B? Of course, yes. We can say that. The reason is because if you look at all the elements that are present here correspond to the elements that are present here. The same position. You understand? If they are not in the same position, we cannot say that they are equal. That is why I put the word corresponding. Are you getting it? Corresponding. The elements that are present in one element in the first matrix must be correspond to the elements that are present in the second matrix. You understand? So that's it. Okay. Having known that, listen to me. Can you tell me the position of this 5? The position of this 5 is in row 3, column 3. Do you know? Yes. This position, the position of this 5 is in row 3, column 3. If you want to learn that, see, this is the third row, right? And this is the third column. You can see that this 5 is in row 3, column 3. Do you understand? I mean, third column is in row 3, column 3. So, what of the position of this one? What is the position of this one? The position of this one is row 2, column 2. Because this is row 2. And if you look, this is row 2. And this is column 2. You understand? So, that is it. The first row, this is the first row. This is the third row. And this is the first column. This is the third column. Do you understand? So, when we say two matrices are equal, the elements that are present in both matrices must be correspond. You understand? They must correspond to each other. Okay? Let us look at work example under equality of a matrix. You understand? Given that, please pay attention. Given that matrix A equals to 1, 2, 4, 5, and matrix B equals to A, B, C, D. Look at that question. This is the question. Given that matrix A equals to 1, 2, 4, 5, and matrix B equals to A, B, C, D, what is the value? Find the value of A, B, C, and D if A equals to B. That's the question. Given that matrix A equals to 1, 2, 4, 5 and matrix B equals to A, B, C, D, find the value of A, B, C, and D if A equals to B. That is, if matrix A equals to B. You can see now that's a typical question that can come under equality of a matrix. You understand? Because just go back to the properties, to the characteristic, to the condition in which we can say two matrices are said to be equal. The condition is this: the elements must correspond to each other. Are you getting it? Hence, if I want to find the value of A, B, and C, the position of A in the second matrix is what? Is row 1, column 1. Do you know? So you are going to go to the first matrix, which is matrix A, and look at the position of the element that is corresponding to where A is. Do you understand? And if you compare, you will discover that A is equals to 1. And the simple reason is because 1 that you see here is also in row 1, column 1. Do you understand? So that means the value of A equals to 1. Now, what is the value of B? Okay, before that, can you just tell me the position of B? The position of B is in row 1, column 2. Are you getting it? This is the first row, this is the second row, this is the first column, this is the second column. The position of B is in row 1, column 2. So you are going to go back to the first matrix and check the element that correspond to B. And if you check, if you compare, you discover that B is equals to 2. So B equals to 2. Now, what of C? What is the value of C? Okay, C equals to 5, Abby? No, that's not correct. C equals to 4. So the value of C is 4. And the value of D equals to 5. Do you understand? Okay, so that's the solution to that question. You can, let me give you, I want to practice this. Given that the below matrix are equal, that is, these are the matrix, this matrix is equal to this, we are asked to find the value of A, B, C, D, E, F, G, and H. And we are also find, okay, let's consider the equation that we have on the board on equality of a matrix. Given that the below matrix are equal, that is, this matrix is equal to this matrix, we are asked to find the value of A, B, C, D, E, F, G, and H. Also, we are asked to calculate A squared minus B squared. Also, the third question, we are asked to find 3A plus 2 multiplied by C plus D. Now, listen to me carefully. I told you, you see, anytime you come across question on equality of matrix, just remember the condition for two matrices to be equal. That is, the element that is present in both matrices must be corresponding. Do you understand? Okay. So if you compare both matrices, the value of A, if you compare both matrices, solution. If you compare both matrices, the value of A will be what? The value of A will be 4. Is that it? No. The value of A will be 1. And the simple reason is because the element that corresponds to where A is in this matrix is 1. Do you understand? Okay, so A is equals to 1. What of the value of B? The value of B will be equals to 4. The value of C will be equals to 7. The value of D will be equals to 2. So D equals to 2. And the value of E will be equals to 1. E equals to 1. And the value of F is equals to F will be equals to 4. F equals to 4. And G equals to 3. And H equals to what? 6. What will be the value of I? The value of I will be what? Will be 9. Do you understand it now? So that is it. Do you understand this? Now, having gotten the value of A to I, now we are asked to find the value of A squared minus B squared. Okay, let me do the solution here. A squared minus B squared, that is the second question. A squared minus B squared. A squared minus B squared. A is what? 1, right? So we are going to have 1 squared minus B squared. B is 4, don't forget. So I'm going to have 4 squared. Do you get it? So I'm going to have 1 squared is 1 times 1, right? So I'm going to have 1 minus 4 squared is 4 times 4, that is 16. 1 minus 16, that is what? Negative 15. That is the solution. And the third question under this question is, we are asked to find 3A plus 2 multiplied by C plus D. Okay? Having known that A is 1, so I'm going to have 3A plus 2 multiplied by C plus D. That is 3 multiplied by 1 plus 2 multiplied by C plus D. C is 7, so I'm going to have 7 plus D. D is 2, so I'm going to have 7 plus 2. Okay? So for this, I'm going to have 3 plus 2 multiplied by 9. Okay? 3 plus 18. 18 plus 3 is 21. So the value of this is equals to 21. Do you understand it now? So these are likely questions that can come out under equality of the matrix. If you encounter this kind of question in exam, solve it like this. You're good to go. You're going to have your answer being marked. Do you get it? Okay. Having talked about equality of matrices, let us now look at the addition of matrices. Please, I want you to pay attention. If you want to have two matrices together, these matrices, they must have the same order. You understand? There is a condition for you to be able to add two matrices together. Are you getting it? If you want to add any matrix together, the matrix, both of the matrices must be of the same order. Are you getting it? So don't forget what you learned about order in matrix. Order refers to the dimension of matrix. Are you getting it? So let's say we have matrix A. Matrix A's are 1, 2, 3, 4, 5, 6. And we have another matrix B equals to 1, 2, 1, 2, 1, 1. 1, 1. Okay? Let's say we have these two matrices. We have matrix A as this and matrix B as this. Is it possible to add both matrices together? It's not possible. The reason is because the order of this matrix is what? Is 2 by 3. You understand? The order of this matrix is 2 by 3 because it contains 2 rows. This is row 1 and this is row 2. So I'm going to have 2 and it contains 3 columns. Column 1, column 2 and column 3. So the order of this matrix is 2 by 3. While the order of the second matrix is 2 by 4. You understand? It has two rows as well, row 1 and row 2, but the column are 4. Column 1, column 2, column 3, and column 4. You understand? So the order of this matrix is 2 by 4. So this matrix cannot be added together. Okay? So the only condition which we can add two matrices together is that they must have the same order. So let's say I now change this matrix. You understand? Let's say I change the matrix. The order will now become what? The order will now become 2 by 3. You understand? That is the order of the matrix. Now, if you compare the order of this matrix and the order of this matrix together, if you compare both order, you will discover that they have the same order now. So at this state, they can be added together. But before, when we have 2 by 4, it is impossible to add the matrix. Do you understand now? So do not forget that. Now, let us find A plus B. Don't forget, the first step is that you first have to verify if the matrices are having the same order. If they are having the same order, you can proceed to add up the matrix. But if they are not having the same order, you cannot add it together. And the reason is because there will be some element that is going to be left out in one of the matrix that is not corresponding to the order. You understand? I'm going to show you, don't worry. Okay. Now let's look at the addition of matrix A and B. Matrix A is this, and matrix B is this. If you want to add this matrix together, you have to add their corresponding element. You understand? You have to sum up their corresponding element. Now, which element corresponds to 1 in matrix B? The element that corresponds to 1 in matrix B is what? 1. So, for this, I'm going to have this 1 plus this 1. Do you understand? Okay? Now, if you look at, we are done with this one. The second element is 2, right? Now, which element, which number corresponds to 2 in the second matrix? That is also 2, right? So I'm going to have 2 plus 2. Then we proceed to the next number, which is 3. Now, which number corresponds to 3 in the second matrix? That is 1. So I'm going to have 3 plus 1. The summary of what I'm saying is that this is A, right? 1, 2, 3, 4, 5, 6. And this is matrix B. Matrix B is 1, 2, 1 and 2, 1, 1, you know. Now, if you want to add this matrix together, this one will add up to this. Are you getting it? I'm coming. We're going to add this one with this. These 2 will add to this, and this 3 will add to this. And if you want to add this one as well, it will be 4 plus 2, 5 plus 1, and 6 plus 1. That means if you want to sum any matrices together, you just have to focus on the corresponding element of both matrices and then sum the numbers together. You understand? So for this, I'm going to have 3 plus 1. So the number that is going to be here will be 4 plus 2. I'm going to have 4 plus 2 here. Then the next one is 5 plus 1. 5 plus 1. The next one is 6 plus 1. Okay? So A plus B is equals to 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 1 is 4. 4 plus 2 is 6. 5 plus 1 is 6. 6 plus 1 is 7. So the sum of matrix A and B is this. Do you get it now? Okay, now I want to practice this. Let's say you are giving matrix X as this. Matrix X as 1, 2, 1, 1, 1, 2, 4, 1, 2. And you are giving matrix Y as 1, 1, 1, 0, 1, 2. Okay, so you are asked to find the sum of, you are asked to find X and Y. I want to do something now. Pause this video, then do the solution. When you are done, then play the video to check your answer. Do you understand? Okay, now let us find the sum of matrix X and Y. The sum of matrix X and Y will be, now don't forget that when we are adding two matrices together, you just have to focus on the corresponding element of both matrices. Since the matrices must have the same order, and the reason why they must have the same order is because so that there will not be element that is going to be left out. You understand? When you're taking the sum of any two matrices, they must have the same order, and the reason is because there will be, if they didn't have the same order, there will be an element that is going to be left out that will not be adding up. Do you understand? So that is it. Now, if you want to take the sum of these matrices, this one, the corresponding element, the corresponding number to this one in matrix Y is what? Is 1, right? So I'm going to have 1 plus 1. Now we have 2 here. The corresponding numbers in element in matrix Y is what? Is 1. So I'm going to have these 2 plus this 1. Are you getting it? Okay, let's go. For this, the corresponding element that corresponds to 1 in matrix Y is what? Is 1. So I'm going to have 1 plus 1. Then here I'm going to have 4 plus 0. Then 1 plus 0. Then 2. Oh, sorry. This 1 plus 1. 1 plus 1. Then 2 plus 2. Do you understand? Okay, so I'm going to have 1 plus 1. 1 plus 1 is 2. 2 plus 1 is 3. 1 plus 1 is 2. 4 plus 0 is 4. 1 plus 1 is 2. Then 2 plus 2 is 4. So the sum of matrix X and Y is this. Do you understand it now? So anytime you are taking the summation of any two matrices, all you have to do is that first check if they have the same order. If they have the same order, then you can proceed to add them together. Let's look at more work example. Find the sum of the following matrices. Okay. Now listen, I want to explain an important thing to you. The reason why the matrices must have the same order, I want to give you an explanation. Let's say we are asked to add two matrices that doesn't have the same order. For example, let's say we have add the following matrix, maybe 2 1 1 2 1 1 plus another matrix, maybe 2 1 4 1. Okay. Now, what is the order of this matrix? The order of this matrix is what? 3 by 2, right? 3 by 2. Why the order of this matrix is what? 2 by 2. 2 by 2. Now, this matrix as you see here doesn't have the same order. If you try adding them, which you are going to try, if you try adding them, you will discover that there will be some element that is going to be left out. And I told you that when I talk about elements, I'm referring to the numbers that will be present inside the matrix. You understand? When I say element, I'm referring to numbers that are present inside the matrix. Do you understand it? So don't get confused. Now, let us try adding these two together. This will be 2 plus 2. 2 plus 2, right? This 2 plus this 2. Then this 1 plus this 1. 1 plus 1. Then this 1 plus this 4. 1 plus 4. Then this 2 plus this 1. 2 plus 1. Then now, you can see that we are still left with what? The third row, which is 1 and 1. There is no element that we want to add this 1 and this 1. There is no element that is present inside the second matrix. So that is the reason why any matrix that will be summed together, they must have the same order. Do you understand? And that's what I mean by and some elements being left out when we are adding together. You can see. So it is very, very important that you pay attention to that. You can only add matrices that have the same order. Hence, if you are given any question and you're asked to sum the matrices together, first thing to check is to check whether the matrices are having the same order. Do you understand? Okay. Let's proceed with the question that we have on the board. Let's start with the first question. We are asked to sum these matrices and these matrices. We are asked to sum it together. If you want to sum these matrices, this matrix and this matrix together, you can see that they are having the same order, right? The order of this matrix is what? 3 by 3, you know? And the order of this matrix is what? 3 by 3 as well. So we can sum it together. For this, I'm going to create a big one. The corresponding elements, please pay attention. If you didn't get it in the first instance, you can get it right now. The corresponding element, the corresponding number that corresponds to 8 in the second matrix is what? Is 1, right? Because this 8 is in row 1, column 1, you know. This 8 that you see here is in row 1, column 1. And this 1 as well is in row 1, column 1. So you can always add this 8 and 1 together. So I'm going to have here 8 plus 1. Do you understand? Okay, we are done with 8. Now let us progress to the next number, which is 3. This 3 is in row 1, column 2, you know. This is row 1. This is row 1. This is row 2. And this is row 3. This is column 1. This is column 2. And this is column 3, you know. So if you want to, the corresponding element in this for 3 is what? Is 2. Because 2 is also in row 1, column 2 in the second matrix. So I'm going to have here 3 plus 2. Do you understand? Okay. For the next one, we have 6. 6 is in row 1, column 3 because it is also in the fourth row. But the column now is what? Is the third column. Do you understand? So it is in row 1, column 6. Row 1, column 3. Now, the corresponding element for 6 is what? In the second matrix, the corresponding element is what? Is 3. So I'm going to have 6 plus 3. Are you getting it now? So, for this, I'm going to have 5 plus 4. These two, I'm going to have 2 plus 5. Then 7 plus 6. Then this 1 plus 7. 1 plus 7. Then 0 plus 8. Okay. Then 4 plus 9, right? Yes. So you can see now. So let's sum it together. For this, you're going to have 8 plus 1 is 9. 9 here. 5, 9, 9, 7, 13. I'm coming. 13, yes. 13. This is 8. This is 8. And this is 13. So the sum of these matrices, this and this, will give us this. Do you get it now? So let us proceed to the next one. Here we are having 3 matrices. We are asked to sum these 3 matrices together. Now, if you want to sum these 3 matrices together, let's start by summing 2 of them together. Okay? Let's start by summing the closed 2. So this one and this one are closed. So let us sum it together. For this, I'm going to have this matrix is 3 by 2. You understand? The order of this matrix is 3 by 2. So we can easily sum them together. First, create something like this. 1 plus 1. This one plus this one. Then this 2 plus this 0. You understand? This one plus this one. Then this 2 plus 0. 1 plus 1 is 2, right? Yes. Then 2 plus 0. That is what? 2. Okay? We are done with the first row. Let us proceed to the second row. Second row is 7, 8, and 1, 7. So this 7 plus 1. 7 plus 1 is what? Is 8. Then 8 plus 7. That is what? 15. So I'm going to have 15 here. Now we are done with the second row. Now let's proceed to the third row. The third row consists of 1, 1, 3, 1. Okay, for this I'm going to have 1 plus 3. That is 4, right? Yes. Then 1 plus 1. That is what? 2. So we are done with the summation of these 2 matrices. You understand? So we can now add the result of the sum of these 2 matrices to the third matrix. You understand? So I'm going to have this plus the third matrix. Do you understand? Here we are summing 3 matrices together. You understand? The first matrix is this, the second matrix is this, and the third matrix is this. Are you getting it? Now I say that we should take it step by step by summing the first 2 matrices. You understand? The ones that are closer to each other. So I sum these 2 matrices together. I got this. Having got this, then we can now sum this result. We can add the result of the sum of the 2 matrices to this, and that's what I'm going to do. I'm going to do now. For this, I'm going to have 9, 8, 7, 1, 5, 4. Okay. Now let us sum this and this together. I hope you know that this one that you see here, the matrix that you see here, is the sum of this and this. Don't forget. So apparently, if you sum this and this together, that means that you have already taken the sum of the 3 matrices. You understand? So for this, I'm going to have 2 plus 9 will give me 11. This 2 plus this 9 will give me 11. We are now on the first row of both matrices. You understand? So 2 plus 9 will give me 11. Why 2 plus 8 will give me 10. So we are done with this. Okay? Let's proceed to the second row. The second row consists of 8, 15, and we have 7 and 1 in the second matrix. So I'm going to have 8 plus 7, that is 15. 15. 8 plus 7, 15, yes. 15 plus 1, that is 16. Okay? So for the next one, we have 4 plus 5, that is 9. Then 2 plus 4 is 6. So the sum of this matrix and this matrix and this matrix is this. Do you get it? Okay? And you can do it you can do it directly, you understand, by summing all the elements together. For example, let's say we are asked to sum this matrix together. Just do it. 1 plus 1 plus 9. You understand? Focus on the corresponding element in both matrices. Since they have the same order, you are not going to be left with any number that is not summed to another number. You understand? Because they have the same order. That is the purpose of adding of verifying maybe the matrix have the same order or not. Do you understand it? So now for this, you're going to have 1 plus 1 plus 9, that is 11, right? Then 2 plus 0 plus 8, that is 10. 7 plus 1 plus 7, that is 15. 8 plus 7 plus 1, that is 16, you know. 1 plus 3 plus 5, that is 9. 1 plus 1 plus 4, that is 6. Do you understand it? Okay, so we are done with the second question now. For the third one, we are having, what is the order of this matrix? Yeah, the order is 2 by 2, so we can easily sum this together as well. For this, I'm going to have 2 plus 3, that is 5, 1 plus 7, that is 8, 1 plus 2, that is 3, 2 plus 10, that is 12. Okay, that is the sum of the matrix. Okay, now what of the fourth example? The fourth example that we're having consists of, what is the order of this matrix? The order of this matrix is 3 by 2. So since both matrices have the same order, they can be summed. Okay, so you can try this by yourself and then tell me your answer. Having talked about addition of matrix, let us look at the subtraction of matrix. How do we take the difference between two or more matrices? That's what we want to talk about now. Okay, so I want to pay attention. Let's say we have matrix. Okay, we can make use of the examples on the board. Before you can take the difference between two or more matrices, they must have the same order. You understand? Just like the addition. You understand? So before you can take the difference between two or more matrices, this matrix must have the same order. Are you getting it? So you can see that the importance, it is very important that you understand what is meant by order of a matrix. Are you getting it? So now let's use this example that we have on the board. If you want to take the difference between this matrix and this matrix, I'm going to have, we are still going to proceed the same way we did the addition. You understand? All you have to do now is that just instead of adding up, you are subtracting. Are you getting it? So for this, I'm going to have 8 minus 1, because the corresponding element to 8 in this matrix is what? Is 1. Do you understand? So I'm going to have 8 minus 1 here, then this 3 minus 2, then this 6 minus 3. I hope you know that this both matrices have the same order. You understand? That is why it is easy and possible to subtract them. If they didn't have the same order, don't bother yourself. You cannot take their difference. Are you getting it? So pay attention to that. Now, for this, I'm going to have 5 minus 4 at the next row. 5 minus 4, 2 minus 5, 2 minus 5, then 7 minus 6, 7 minus 6. Then for the third row, I'm going to have 1 minus 7, 1 minus 7, 0 minus 8, then 4 minus 9, 4 minus 9. Do you understand how I got this? What I'm doing was, this is what I did. I just subtracted the corresponding elements that are present in the first matrix from the corresponding element that is present in the second matrix. You understand? So it's very simple. This is simple, okay? Just pay attention. So let us take the difference. For this, I'm going to have 8 minus 1 is 7, 3 minus 2, 1, 6 minus 3, 3, 5 minus 4, 1, 2 minus 5, negative 3, 7 minus 6, 1, 1 minus 7, negative 6, 0 minus 8, negative 8, then 4 minus 9 is what? Negative 5. So that is the solution to that question. Now let us proceed to the second one, to the second question. The second question, you can do it directly and you can also do it step by step. Are you getting it? So let's do it step by step. Let's first take the difference between this matrix and this matrix. Are you getting it? So 1 minus 1, that is what? 0. Okay, so I'm going to have 0 here. 2 minus 0, that is what? 2. Do you know what I'm doing? The corresponding element to 1 in the second matrix is what? 1. So I'm going to have 1 minus 1. 1 minus 1 will give me 0. Are you getting it? Just like what I did in the previous examples. That the same thing I did was what I'm trying to do here. Okay. So for this, I'm going to have 7 minus 1. 7 minus 1. 7 minus 1 is 6, Abi. Then here I'm going to have 8 minus 7. 8 minus 7 is 1. Now for the next one, we have 1 minus 3. So I'm going to have negative 2. And then 1 minus 1. That is what? 0. Okay. So we are done with the difference between this and this matrix. Now we can now take the difference between this matrix and this matrix and then find the difference of this. This is what I'm trying to say. Just like we did in the previous example when we are taking the addition of the matrices. What did I do first? I first take the sum of this and this. I take the sum of these matrices and these matrices. Then having taken the sum, then I add the result to the third matrix. That's the same thing is what I'm trying to do here. I first take the difference between these matrices and these matrices, then I obtain this result. This result also, I'm going to subtract this from this result. Do you understand? To get the difference between the three matrices. Are you getting it? And you can also do it directly. Are you getting it? So you didn't have any problem doing it directly. Of course, this kind of question usually come out in the objective. So you can just do it, without showing your workings, and then you get your answer. But if it comes out in the theory, you can show your full solution. Do you understand? Okay, so now for this, I'm going to have minus 987154. So for this, I'm going to have 0 minus 9. 0 minus 9 is negative 9. I'm going to have negative 9. 2 minus 8, that is what? Negative 6. 6 minus 7, that is negative 1. Then 1 minus 1, that is what? 0. Then negative 2 minus 5. Negative 2 minus 5, what's the answer? That is what? Negative 7. So I'm going to have negative 7. Then 0 minus 4, that is what? Negative 4. So the result of the differences between the three matrices is this. Do you understand? And now let us check whether we are correct. To check whether you are correct, you just have to do like this. Focus on the corresponding elements in the three matrices. Then take their differences. Do you understand? Okay. 1 minus 1, 0, Abi. 0 minus 9, that is what? Minus 9. Okay. 2 minus 0, that is what? 2. 2 minus 8, that is what? Minus 6. Do you understand? And for the next one, we have 7. 7 minus 1, that is what? 6, right? And then 6 minus 7, that is what? Minus 1. Do you get it? Then for the next one, we have 8. 8 minus 7, that is what? 1. Then the result, which is 1. 1 minus 1, that is what? 0. Do you understand it? Okay. For the next one, we have 1. 1 minus 3, that is negative 2. Negative 2 minus 5, that is what? Minus 7. Okay. For the next one, we have 1 as well. 1 minus 1. 1 minus 1 is what? 0. Okay. 0 minus 4 will give me what? Negative 4. Do you get it now? Now, let's proceed to the next example. For the next example, we're going to have 2 minus 3. 2 minus 3. This 2 that you see here minus this 3. Then 1 minus 7. 1 minus 7. Then for this, I'm going to have 1 minus 2. 1 minus 2. Then 2 minus 10. 2 minus 10. Okay. The answer will be 2 minus 3 is what? Negative 1. 1 minus 7 is what? Negative 6. 1 minus 2 is what? Negative 1. Then 2 minus 10 will give me negative 8. So the result of the difference between this and this is this. Do you understand? Okay. For the next matrices, I want to try it by yourself and tell me your answer. Try it by yourself and tell me your answer. Or you can pause this, then when you are done, play it to check your answer. Maybe you are correct. Okay. Now 1 minus 4 is what? Minus 3. 2 minus 3 is what? Minus 1. 4 minus 2 is what? 2. 5 minus 5 is what? 0. 7 minus 1 is what? 6. Then 3 minus 0 is what? 3. Okay. So that is the solution to that question. So you've learned the addition and subtraction of matrices. Now let us look at the multiplication of matrix. You see,